I got some table evidence.
Yeah.
Alright, what you got?
He just randomly put 7, and then I was like, yo, you got 7 days a week. Like what she said.
Alright. So, if there's always the same number, like if all the cages are always full, are you going to make more money on a different day or less money on other days, or you make the same amount of money every
I
week?
mean, it's fulfilled every day. It makes it different.
Right. So does this tell us anything? Are we adding on cats each day or dogs?
No, we're supposed to like be like, okay. I feel what you're
So you're
talking
kind of like modeling one day, like what's most important.
Oh.
Okay.
Okay.
So
You're like, okay.
the thing about your constraints, how can you model those constraints in a table? Alright. Table group. What'd you start with? What'd you think? To start with, what were your ideas on how to represent?
So you see, we did like days, and then we correlated that with like the amount of money they had to pay, but then found out that it was wrong. So,
Why though?
Because like once they like capped on the amount of animals, they can't like keep on adding them.
Okay. So because the dogs and cats are always filled up,
Yeah.
how much we're going to make each day is the same, right?
Yeah.
Okay. So another way to think about this is what is on the camera right now. Okay? So you have different combinations of cats and dogs that you can have. And that's going to give you a different cost, and it may or may not fit within the constraints. So do you want to talk about what you were starting to do here?
We were trying to find different numbers of the cat and dog to get the most money earned.
Okay. Do you care if I continue your table?
That's fine.
Okay. So if we know that our cost is 476, how did we get 476? Here's a calculator. I'm gonna check real quick. What should I multiply? 80 plus 12 times 32. And that's going to be our cost. So this gave us 1,344, right? That's how much it's going to cost to have 12 cats and 12 dogs. Does that fit within our constraint of only having 1280 to spend? No. Okay? So 12 and 12 doesn't work. What the dad suggests is not going to fit with how much money we need. Okay? But what if we had, let's say, 0 cats? What if we only did dogs? How many dogs can I have? How can I figure that out? If I have 1280 to work with, how can I figure out how many dogs I can spend for? Divide by 80. Why? So per each dog is 80. So if we divide it, what's 1280 divided by 80? 16? Sweet. And that gets us right on the mark. We spent all our money. Okay? Now if I want to continue this table, what if I just pick a number that's less than 16? Because we know 16 is the max, right? So if I say I want 15 dogs, how much money is left over for cats? 2? 80. So if we do 1280, and we're subtracting 80 from that, because we're doing one less dog, right? I got 1200. So now we have spent 1200 and there's 80 left. How much does it cost per cat? 32. So 80 divided by 32 gave me what? 2.5. Does that make sense? Can I have 2.5 cats? Not legal now. Okay? And that puts us right at 1280 again. Okay? So in real life, let's talk about real life. You can't have 2.5 cats. So when you have 2 cats or 3 cats? 2 cats. Okay? So I'm going to put in parentheses 2 beside it. And over here in parentheses, how much cost would that actually make? Okay? So if I want to keep going with this, right, I can do 14 dogs, and then how many cats does that leave me? You can use your calculator real quick. Who said 5? Did I hear 5? Yeah. Okay, 5. And that's going to put us right at what number? Okay. So, are we seeing a pattern here? Is this linear or not?
Yeah.
Okay, keep that and we're going to come back to it. Now, let's make another table for space. Because that's another constraint, right? Let's take the same approach. If I have 360 square feet of space, if I didn't do cats, how many dogs can I have? 15. So we take 360 divided by what number? 24, we get 15. So if all of our space was just dog kennels, we can fit 15 in there with 0 cats. And that gives us our 360. Looking good? Now let's do the same method. Let's do 14 dogs. How much space is left for cats? How many cats can I fill? 5? So if I do 5 times 6 square feet for cats, plus 14 times 24 square feet for dogs, I get 366. So that's over 360. But we can subtract 1 cat, right? And we can get 4 cats, and that puts us at 360. You see where I'm going with this? Do 13 dogs. Can you give me a guess about how many cats that's going to be? 3 cats? Wouldn't our cats go up if we reduce the amount of dogs? 5? That's a good guess. Because it's 8. Why 8? Sweet. Exactly. So here we went from 0 to 4, and that was a change of 4. And this was a change of 1. So if we change 1 again, we can expect this to be a change of 4. Okay? Pretty good. So this is a really good way to represent this situation with some tables. Equation group. I saw some nice things going on. Do you want to... I'm already feeling names. Okay. So, do you want to come up and show me what this is and explain the variables?
I think you can do it.
Everybody get this down? Everybody see what's going on? So this was to meet our cost, and this was to meet our space. Alright, you want to come show it? No? I can show it. I might ask you some questions about it. Okay, let's talk about some of these equations.